When we talk about fine touch to the head, we're going to try to make our lives a little easier by just looking at the fine touch to the head associated with cranial nerve 5. Understanding that, yes, we would have fine touch through 7, 9, and 10, but we're not going to go into that. You've got enough to learn. So we're going to begin again as some sort of receptor. And we're going to see that we're going to have nerve fibers that are going to be traveling through cranial nerve 5-1, 5-2, or 5-3. And these nerve fibers are going to have their cell bodies in the trigeminal ganglion. Okay, the trigeminal ganglion. These nerve fibers are going to then come into, first of all, the principal sensory nucleus of cranial nerve 5. We'll write that over here. And once again, I'll just put a 1 on that and a 1 over here. But also, some of these nerve fibers are going to go into the pars oralis portion of the spinal nucleus of cranial nerve 5. So we're going to see that we're going to have nerve fibers that are going to come into principal sensory nucleus, but also into the pars oralis portion of the spinal nucleus of cranial nerve 5. It is way beyond the scope of this course for us to talk about exactly what modalities go into one nucleus or the other. So we're not going to go into that. Our second order neuron is going to come out of the principal sensory nucleus, come out of the pars oralis portion of cranial nerve 5. These fibers are going to cross the midline in the reticular formation. They are then going to ascend in the anterior trigeminothalamic tract, where they will enter into the VPM nucleus of the thalamus. And then our third order neuron is going to come out of the thalamus. It is going to go through the posterior limb of the internal capsule, where it will project to area 312 associated with the head. So this is the main pathway associated with fine touch to the head. But there is a backup system. Coming out of the principal sensory nucleus, we are going to have nerve fibers that are going to ascend on the same side through the posterior trigeminothalamic tract, and these nerve fibers are then going to come out, stay on the same side, go through the same side posterior limb internal capsule, and go to the same side area 312 associated with the head. This is considered to be kind of like a backup system to our fine touch to the head. And as such, what that means to us is that fine touch to the head must be very, very important for the survival of the individual. The last modalities that we want to look at associated with the general sensory pathways are going to be those pathways associated with proprioception. Or if you like, where are we in space? When we look at these pathways can be divided into two parts. There is what is called unconscious proprioception. And this is going to be proprioception that we don't think about. And as such, these fibers in these pathways are going to go to the cerebellum. But then we also have conscious proprioception. In other words, we can tell people where our arm is at any given time. Conscious proprioception, since it is conscious, has to go through the thalamus and then up to the cerebrum so that we can consciously perceive it. So what I want to do on this template is I want to look at unconscious proprioception as it pertains to the upper half of the body. And again, we're using T6 as our reference point. When we look, we are going to have receptors. And these receptors are either going to be muscle spindle fibers, which use 1A type neurons, or Golgi tendon organs, which use 1B fibers. For testing purposes, you can use one of these, the other of these, or both of these as you start this pathway. Again, this is not neurophysiology class. We are going to see that the cell bodies for these neurons are going to be located in the dorsal root ganglion. These neurons are then going to come in and ascend through the cuneate fasciculus. And they are going to end in the accessory cuneate nucleus. From here, we will have neurons that are going to go through the cuneo, cerebellar tract, that tract is going to go through the inferior cerebellar peduncle into the cerebellum. So notice that this tract is, first of all, going to stay on the same side. It doesn't cross the midline. Secondly, notice how this tract goes to the cerebellum. So it will be an unconscious modality. We don't actually perceive unconscious proprioception.